So here is an example of bouncing projectiles. A particle is thrown horizontally with a speed of 10 meters per second from a point 2 meters above a flat ground, with a coefficient of restitution E equals a quarter. Find the speed of the particle upon impact, then the speed of the particle after bouncing for the first time, and the percentage difference in the range of the particles. Hence show that the ratio of the ranges is E, where Rn is the range after the nth bounce. So this is, quite a difficult challenge, it's a challenging problem to kind of think of. So when you're ready, you can have a stab at it and then come back for the solution. So the solution here is actually quite long. I will sort of split it. So I'll split it here, and then I'll split it here. So kind of split it into 3 sections. So in the first one we have our diagram. So initial velocity 10. That's never going to change because we're colliding along a floor. So Vy is actually the one that changes. So I should have actually Vy instead of Vx. But it says Vy here, or it represents Vy here anyway. So in falling down, the velocity of the y component reaches 6.26 meters per second. And then after colliding, the coefficient of restitution is a quarter. So a quarter is minus v over 6.26. So its new velocity will be 1.57 meters per second going up. And here are the diagrams of the 2 velocities now. Obviously they're not to scale. They're actually wildly not to scale at all. But the magnitude of the velocity is 11.8 from squaring these and taking the square root. And here it's 10.1. So we need our u, and we also need sine theta and cos theta. So we've defined theta as this little angle, these little angles in here. So if we put it into our range equation, we get 2u squared sine theta cos theta over g, and the first one is 12.8. So this 12.8 is actually taking the whole parabola into account. So in reality, it should have been half of it, but we're going to take the whole parabola into account here. If you've taken half the range, then it'll be 3.2, or half of 12.8. So you actually end up with twice the coefficient of restitution in that case. But it's still a nice representation of finding the coefficient of restitution given the ratio of the 2 ranges. If one of them, say, starts from the ground and then hits twice. A challenge for any viewer is to come up with a recursive formula that finds the new range given the first range and the coefficient of restitution. So there's a little extra challenge if you found this problem very easy.